is so good. How can I like skin dive as far as you can?
Did you ever heard of Six Sigma? I think yes, romances can improve your skin diving distance. I think the first one is the depth of your swimming, and second is your style, and third is what you wear. It's the swimming suit. Let me show you some explanations to use the Sigma method to improve your skin diving distance.
After taking the Six Sigma course, the concept of DMAIC are being implemented for improving the skin diving distance. First, let us take a look at the define phase. First question, why should we analyze skin diving? Because when we compared with normal swimming, for example the freestyle, butterfly and breaststroke, the only factor determines the outcome is swimming speed. However, skin diving is affected by not only the swimming speed, but also the breath holding time. So, skin diving is more complicated to analysis. In this project, we define the output, y, to be how far one can dive in one breath. For the x, there are two factors, swimming speed and breath holding time. The breath holding time is influenced by the lung capacity and diving depth. Besides, the swimming speed is influenced by the water temperature, swimming suits, and swimming styles. After the define phase, we now have to move on to select the important critical to quality, the CTQ. In the QFD diagram, there listed the requirements for improvement on the left vertical axis, and for the small y, the factors that are subjected to measure are listed on the upper horizontal axis. After completing the QFD, the important factors to improve skin diving distance are, first, the most important one, is the swimming styles, which includes freestyle, butterfly stroke and breaststroke. Second, diving depth. Third, mass to lung capacity, which varies by people. However, the mass to lung capacity remains constant in the 14 testing days for each person. Last, the swimming suits, for instance, the normal swimsuits and the beach shorts. In the measurement experiment, we choose the white floating buoys for the measurement reference, where each white buoy represents 1 meter. To evaluate the measurement system, we launched a repeated test to read the location of an object in the pool. Treated the buoy as a ruler. The number of operators is 2, and there are 9 parts in the test and each measurement is measured twice. For the gauge R and R error, the error is 5%, which means it is acceptable. Also, from the parts times operations interaction diagram, the pattern of the two operators are similar, it means there is no interaction of data by the recorders. Further about the experiment facility, we simply use the campus indoor swimming pool in winter season to maintain testing conditions stable. For example, the pool size is stable, which is 25 meters. And the water temperature is stable as 25 degrees Celsius. In the analyze phase, a cause-effect diagram is demonstrated and swimming styles, dive depth, swim equipment, and mass to lung capacity are selected as parameters from the QFD. Here in the fishbone diagram, we selected the important factors. From the Pareto diagram, we can see those 4 factors dominate a total of 84% importance. In the improve phase, an experiment was designed to investigate the effect of swim styles, depth and equipment for improving the diving distance. For the styles, there are 3 levels, freestyle, butterfly and breaststroke. For dive depth, the levels are top, middle and bottom of the pool. And for equipment, there are beach shorts and normal swimming suits. In total, there are 18 combinations of tests. And each combination was tested for 2 times. So 36 data was logged for each tester. In our study, there are 3 testers, Felix, Memphis, and James. In the Pareto chart, we can see how the human factors influence the outcome. From the 3 charts presented, swimming style dominates for all 3 people. But, there are some difference in factor B, the dive depth and AB, their interaction. Considering that people react to the pressure differently, in order to generalize the issues, we choose James data in our following analysis. In this stage, we have already identified that there are 3 factors we should focus on in order to improve our skin diving distance. They are diving or swimming styles, dive depth and pool size. However, it is impossible to adjust pool size while we are diving, so the third factor is chosen to be the swim equipment, which we can simply change before any time we dive. After doing the experiment that diving styles, depth and swim equipment are being tested, the results were punched into Minitab and the DOE analysis had been conducted. In this Berto chart, it can be seen that only styles, and diving depth, and their interaction are the three terms we should focus on because equipment is not significant factor according to the chart. The result is confirmed by the analysis of variance where only items with P less than 0.05 should be considered. Let's take a look of the residual plots, main effect plot, and the interaction plot before excluding the equipment term. Now, the equipment factor has been removed and the DOE analysis has been done using Minitab. From the residual plots, the residuals follow normal distribution with a mean of 0 and a constant variance. So, the result is good to do interpretation. For the interaction plot, it can be seen that there are interaction between breaststroke and depth. It may possible attribute to a better performance of breaststroke under deeper water. And for shallow dive, performance is better for breaststroke too because diver need not to establish a deeper condition, so only dive distance need to be focused. For the main effect plot, we can conclude that to achieve a longer skin dive distance, breaststroke and shallower dive depth should be used and maintained. In the control stage, it is used to make sure that the conclusion in the improve phase is well implemented and maintained. After the improve stage, we have already identified that breaststroke and shallow dive can result the furthest distance. To select a suitable tool for the control process, the presented flowchart should be used. As we are having discrete data and the sample size is constant, NP chart should be used. So, in this stage, test would be done to count the number of non-conforming to see if the method has been nicely implemented. For the tester, James, non-conforming of the implementation is defined to be how many times that his skin dive distance is less than a number. Because he can dive at most 36 meters at any other strokes and dive depth, so anytime he dives less than 36 meters is counted as non-conforming. Test was done with sample size of 5 and the number of sample is 15. The result is shown by the NP chart because the occurrence opportunity is constant for the tester and result we measured is discrete data and the defect was by counting. To sum up, by using breaststroke and dive shallower, we can achieve the maximum skin dive distance in one breath.